Okay, so we're going to solve this quadratic inequality 2x squared plus 5x is greater than 3. That I'm going to show you is how to do it graphically. Okay, in order to solve it graphically, we're going to start by getting 0 on this side. So we need to subtract 3 from both sides of this inequality, and we end up with 2x squared plus 5x minus 3 is greater than 0. So then step 1 to solve this is going to be to graph this quadratic. Okay, before I get into the details here, I'm just going to notice one thing. Actually, I'm going to notice two things. The first is that it's a degree 2 polynomial, and we know that the graph of a degree 2 polynomial is going to be a parabola. The second thing that I'm going to notice is that the leading coefficient here is positive. So it's a parabola with a positive leading coefficient, and so I know that the graph is going to open upwards. So when I graph it, it's going to look something like that. So to get some precision to it, I'm going to find the x-intercepts of the parabola. Finding the x-intercepts is the same thing as solving the equation 2x squared plus 5x minus 3 equals 0. To solve this, we'll factor it, so you should pause it right now and do that by trial and error. So you should get 2x minus 1 times x plus 3 equals 0, and the solutions to this are x equals 1/2 from this one, and x equals negative 3 from this one. Okay, so we know that the graph of this is a parabola that opens upwards and has these as the x-intercepts. So let's just plot a quick sketch of that. Okay, so here I've plotted the two intercepts, and so at negative 3 and at 1/2. And that's actually all the precision that I need in the graph. So now I know that the graph looks like this and passes through these two intercepts. So, and I know that the vertex is halfway between these two intercepts. Okay, and I don't care where the y value is. So we have this parabola that looks like that. Okay, so that's the graph of y equals 2x squared plus 5x minus 3. Then the next step that we have to do is basically just examine the graph to look for the x values for which the inequality is true. Okay, so we're looking for where 2x squared plus 5x minus 3 is greater than 0. Okay, greater than 0 means positive. So we're looking for which x values is 2x squared plus 5x minus 3 a positive number. Graphically, the outcome of this is positive for all the x values where the graph is above the x-axis, because above the x-axis means positive y values. So the solution to this is all of the x values that correspond to this part of the graph and this part of the graph. So we see here at 1/2, this is equal to 0, but to the right of 1/2, the graph goes above the x-axis, so that means that this is positive. So one part of the solution to this is from 1/2, and for every x value bigger than 1/2, and that means 1/2 to infinity. Okay, now there are other x values for which 2x squared plus 5x minus 3 is positive. Well, at negative 3, it's 0, but if you go just to the left of negative 3, then the graph is above the y-axis. So to the left of negative 3, all the way down to negative infinity, the y values here are going to be positive. So we also have everything from negative infinity to negative 3. And the way we connect these two intervals is by putting a union sign. I'm going to clean this up a little bit because usually when we write solutions in interval notation, we go in increasing order. So for my final answer, I'm going to put negative infinity, comma, negative 3, union 1/2 to infinity. Okay, so this is how we obtain the solution to an inequality graphically.